Good morning, good afternoon, good evening to everyone attending today's webinar. We have some exciting things for you in store. Let me share my screen. So today we will be talking about air pollution monitoring with Copernicus. And for that purpose, we have some really exciting speakers here with us today. We have several speakers from the European Centre for Mid-Range Weather Forecasting, or ECMWF, who is in charge of the Copernicus Atmosphere Monitoring Service. So they are the real experts at the source of the service for anything related to air pollution and air quality. Vincent-Henri Puck is the head of the Copernicus Atmosphere Monitoring Service and a deputy director of the Copernicus department at ECMWF. Then Mark Parrington is a senior scientist in the Copernicus Atmosphere Monitoring Service development section, where he works on wildfire emissions and emissions from anthropogenic and natural sources and their influence on global atmospheric composition. Julia Wageman is an independent consultant working in the intersection between data users and data providers to make the large volumes of meteorological, climate, and air quality data better accessible. She has worked with Jupyter Notebooks since 2014, and in collaboration with a small startup WEkEO and EUMETSAT, she has developed a Jupyter-based training on atmospheric composition data, including Sentinel-5P, Sentinel-3, and data from the Copernicus Atmosphere Monitoring Service. And then, if you've attended one of the webinars before, we also have with us today Amin El Amrani from the WEkEO user support, who's a satellite imagery expert, specialized in any technical issues with the WEkEO DS. And then myself, I will be moderating today's session as part of the WEkEO user support team. So how will we tackle today's webinar? We will start with an introduction to the WEkEO website and what is the WEkEO DS, what it actually offers to you as a user. Then we will be talking about the WEkEO IT infrastructure, so really the cloud that is behind the WEkEO DS. I will start with a short introduction to the WEkEO data catalog, which is quite large. And afterwards, Mark will give a more detailed presentation about any of the data sets related to air pollution monitoring that are available in WEkEO, which is also of the topic of interest today. And then Julia will give a live demonstration of air pollution monitoring with Copernicus data using a Jupyter notebook. Towards the end of the session, we will have a Q&A session. And I just want to point out to you that if you have any questions in the meanwhile, you can always put them in the chat. As you may see, when you next to type your message in the chat box, there's a little bubble with a question mark. Use that for the questions that you have that you really want to get answered from our experts today, in either through the chat or in the Q&A session at the end of this webinar. And then if you then come up with any other questions afterwards, we're always available at WEkEO user support, either through the website, through Twitter, or through our service desk email. But I will now give the floor to Vincent-Henri to give us an introduction to the WEkEO DS.
Thanks.
Good morning.
Good morning, everybody. So I'm Vincent-Henri Puck. I'm the director of the Copernicus Atmosphere Monitoring Service, one of the 6 services of Copernicus, and representing ECMWF, who is one of the partners behind WEkEO. So let me start by answering the question, what is WEkEO and what makes WEkEO unique? So WEkEO is part of Copernicus. Copernicus is the world's most ambitious Earth observation program. It generates vast amounts of data, about 10 terabytes of fresh data every day. And these 10 terabytes are used by more than several thousands of users on a daily basis. So you immediately see that there is a need for streamlining, providing solutions for handling this vast amount of data. And part of the solution is through so-called DIAS, Data Information and Access System. There are 5 of them, and WEkEO is one of them. What makes WEkEO stand out from the other one? A key aspect is that it's under the responsibility of partnership between key stakeholder organization of the Copernicus program, EUMETSAT, ECMWF, where I work, Mercator Océan International, as well as the European Environment Agency that has joined the group to build together WEkEO. So it's all international or European public institutions, but it doesn't mean that these European public institutions are implementing WEkEO. Quite the contrary, WEkEO is implemented through a number of procurements, and it's industry that is behind the services that are delivered to the users. What do you find in WEkEO? So first, you find a contact with the partners, and as I said, with Mercator, EUMETSAT, European Environment Agency, and ECMWF, you have a direct contact to the data producer for most of the Copernicus services and the space segment. And if in WEkEO you find, like in other DIASes, access to all the Copernicus data, the data from the 5 services for which the data is full, free, and open, and the data from the Sentinels. What WEkEO brings is a cloud computing infrastructure, as will be presented later, a number of tools, but also support to the users as well as a marketplace. A few examples. There will be a more detailed talk by my colleague Mark Parrington. What do you find in WEkEO regarding the Copernicus Atmosphere Monitoring Service, which is our atmosphere monitoring information in WEkEO? One example is daily air quality forecasts. So these are the data that are behind, for instance, the daily air quality bulletin that you will see on Euronews or CNN. But it's much more than air quality, the pollutants. It also gives numerical data about intrusions of sarin dust, for instance, as you can see in the bottom of this view graph, or information about pollens in the next few days. Another example of exciting product that you can access through WEkEO are emissions of greenhouse gas or pollutants. It's estimates that are prepared by experts of the different pollutants and different processes. Here are the few graphics that I've pasted are regarding emissions of methane over last year. And it shows for different regions in the world, our best estimate of the emissions, both by anthropogenic processes, but also by natural processes. Final example, just to give you a flavor, again, my colleague will go in more detail. You can find also information about solar radiation. Solar radiation is part of the atmosphere monitoring portfolio because it is influenced by ozone, by aerosol, by clouds. And here is an example from University College Cork in Ireland of comparison between our products and local measurements that are made in a site in Ireland. So with our products, which provide a large geographical and temporal coverage, basically you can have this information anywhere in the world, even where you don't have sensors. So lots of data and information, and this session will allow you to play a little bit with that. So let me articulate to finish this introduction the unique features of WEkEO. So the partners of WEkEO are the producer of the data, so it's a first-hand contact to the data producer. The other very important feature is that WEkEO is implemented in a geographically distributed way, so that data is not copied on WEkEO. WEkEO provides an interface to data that is distributed all across Europe. So the data stays where it is, and the infrastructure allows the user to work with it. Other features which are very important, in WEkEO, we put a very strong focus on the user development and user management. This is done in many ways. One way are webinars like today, or material that you can find in the form of guides or frequently asked questions or videos. But also, you can access real people answering your question. And for that, WEkEO has introduced a two-tiered system. There is a dedicated user support team that can answer fairly easy questions or generic questions about accessing the data. But also, because it's WEkEO, you can have access in a second level to detailed question that can be answered by the experts. So in our case, for instance, you are interested in pollen forecast, and you want to know what are all the different pollens that are provided with forecast, and what is the quality of the forecast, for instance. And this is something that through WEkEO user support can be answered. Another feature of WEkEO before finishing, as I said, it's a place where all the different streams of Copernicus come in the same place. And here is an example of something we've done, trying to put on the same view graph a time series. So this is Athens. This is last year with the first half of 2020. And what we wanted to overlay on the same view graph are two things which in principle are different. One in red is what the Sentinel 5P satellite is measuring in terms of nitrogen dioxide, which is one pollutant. Actually, the satellite sees a vertically integrated column going from the surface up to the ground. And we wanted to compare that with a different but related quantity, which is the surface concentration of this same pollutant, NO2, that we have in the CAMS analysis and forecast. And what is nice, so the units are different for the red curve and the black curve, but what you see is that there is a very good correlation between the two, meaning that the variations from one day to the next that the satellite sees, and that the surface, the information about the surface is provided by CAMS are matching very, very well. So it means that you can use those two sources consistently to develop further application. And having this data set in the same place makes things like this possible. It's just an example. So to finish, WEkEO is also a community. So you may know already the web portal, Twitter, but also the service desk email that can give you access to this user support. Thank you very much for your attention.
Thank you, Vincent-Henri, for the introduction. We will now quickly go over to Amin, who will show us a little bit about the IT infrastructure for using these data. You're on mute, Amin.
Do you hear me now?
Yes.
Okay, I'll restart it. So I was saying good morning, everyone. My name is Amin, and I'm part of the support team of WEkEO. So I am going to do a brief presentation of the IT infrastructure of WEkEO, which consists of two main services, the Jupyter environment and the virtual machine. So for those of you who are familiar with WEkEO, you can see that we have a brand new website now. So the website comes with a more intuitive design. There is a documentation section that has been revisited. So do not hesitate to take a look at the documentation section and the FAQ, maybe before sending us a message, because you might find your answer there. So let's start with the Jupyter Notebook. So all you have to do to have access to the Jupyter Notebook is to register to WEkEO. So you click register on the upper banner here, but you can also sign in if you already have an account. So here I'm using one of my accounts. And then you click on the username tab on the top right. So that's one of the changes that come with the new website, which is a link to the dashboard in this new version of the WEkEO website. Okay, so you have to click to Jupyter Hub afterwards on the dashboard. So what is the Jupyter Notebook? It is an open source web app that you can use to create and share documents that contain live code, equations, visualizations, and text. And this is the welcome page of the WEkEO Jupyter environment. You have access to a classic Python interpreter, to a terminal prompt that allows you to browse through your Jupyter environment, because as you know, the Jupyter environment is a small virtual machine environment after all. So you can whether create a document from scratch or play an existing file, which you will most certainly do in the webinars and the training. So Jupyter is a very useful teaching tool, as code is associated to text and images. And I will show you that in one of the typical Jupyter notebooks, which is the WEkEO Harmonized Data Access documents. That is available on the folder public WEkEO HDA. Then you click on the WEkEO Harmonized Data Access documents. So you have images, you have text, and you have also these code cells which can be played and which contain Python code, and you can play them by clicking the small play icon here. And once you click it, the code will be executed as if you were on a Python interpreter. And the outcomes and results of the code running are actually displayed in the document itself. You can have also graphs that can be generated if you are drawing a graph out of WEkEO data that you have downloaded. In this document, I will advise you to read this document in particular because it contains all the information on how to get the data, basically, by following all the steps. And you can copy, for example, the HDA request, which is the description of your request. And there is a code that is encapsulated in the Python function used here that will allow you to target a certain number of products of interest. And these products, at the end of the code running, will be downloaded using other functions in the following code cells later in the document. So this is one of the many introductory documents that contain educational instructions that will be presented by numerous experts on different topics through the webinar. And getting familiar with these documents will make you comfortable with the Jupyter environment in a matter of hours. It's not very difficult to handle. And last but not least, these documents can be exported to PDF or to pure Python code if you want to use it elsewhere, for example, by running the code of these Jupyter notebooks on a virtual machine. So this brings us to the virtual machine environment, and some of you might ask, why would we need a virtual machine environment? Isn't the Jupyter environment enough? But the Jupyter notebook environment has limits. It's not meant for long and heavy processing. The storage capacity is limited. CPU and memory are also limited. So it's ideal for testing and mingling with data, if we can say, but not meant for heavier processing. So if you want to perform some heavy processing, consider switching to one of our virtual machines, because WEkEO has a virtual machine resource offer. So how do we request a virtual machine? So you should go to the dashboard, and at the end of the page, you have this upgrade plan button. Once you click the button, you can choose the configuration that corresponds to your needs. So you have this plan size here. You can choose the plan size. You can also give us some information about the data that you will use. You can also use this free text area to give us some more information. And at the end of the page, you have this table that contains the different configurations that correspond to each name, to each t-shirt size. But there is a better table, if you can say, on the pricing section. So at the end of this page, you have this detailed table that contains information related to each t-shirt size. And you can see that it's a pay-in service, but we also have this trial period here that is stated. And as you can see, the smaller the plan, the longer the trial period that goes with it. We have to say also that these trial periods are indicators only. They can be negotiated on a case-by-case basis. And you should contact us on support@wekeo.eu. We will put you in contact with the commercial department of WEkEO. So once these resources made available for you, we advise you to follow the guides to create instances of a virtual machine. You will mainly organize your resources via the Morpheus interface that is also accessible through the dashboard. And once done, you will be able to download and process your data as if you were on your personal computer, yet with this large computing capacity that is offered by WEkEO. So to follow the docs, you click on this docs section, and if you follow the virtual machine articles here, you will be able to create instances of your virtual machine and to access it. It's a Linux prompt that you can use and you can exploit the WEkEO data through it. If you have any questions, I would refer you to the webinar number 3, where there is a demo on how to download the WEkEO data on your Jupyter Hub and on your VM also. So the webinar number 3 accessible in the WEkEO YouTube channel. And I think that's all from me. So I pass it over to Anne-Catherine. And thank you very much.
Thank you, Amin. So now you know how the WEkEO DS works and what you can expect from the interface. I will start with a very brief introduction to what you can find in the data catalog, but with a focus on the non-air pollution data sets. So as was mentioned already before, the WEkEO DS gathers all of the Copernicus data and information from the Marine Environment Monitoring Service, the Climate Change and the Atmosphere Monitoring Service, the Land Monitoring Service, and then the satellite data from the Sentinels 1, 2, 3, 5P, and soon also Sentinel-6. And so what can you get from those services? The Copernicus Marine Environment Monitoring Service provides information about the oceans on a global level. So you have spatial coverage really in the global oceans, and with a more detailed spatial coverage in the European oceans. It provides both parameters related to the blue ocean, so temperature, salinity, waves, sea level, the green ocean, productivity in the ocean, in the sea, acidity, turbidity, things that influence the productivity, and then white ocean, which is the sea ice in the Arctic. Then you have, I'm skipping the Copernicus Atmosphere Monitoring Service, but the Copernicus Land Monitoring Service provides land cover information, both at a global level, whereby you can also find in the Global Land Monitoring Service the biophysical parameters related to snow cover extent, lake ice extent, the surface albedo, top of canopy reflectance, leaf area index, as well as global land cover. Then you have the pan-European component, where you get some more detailed land cover information across Europe. And at a local level, really high resolution information about land cover in specific regions, for example, riparian buffer zones, urban areas, coastal areas, but also very specific information about tree cover density, the measure of imperviousness, so that might also contribute to any of the solutions that you might be developing. And then the Sentinels, which come if you look for the Sentinels in the single or in the source data hubs, they come from either EUMETSAT for anything related to marine data, or from ESA, which is more the land data, but also Sentinel-5P, which will be touched on later on as well. But all of those you can also get them from one single access point here through the WEkEO DS. And then how can you find them? As Amin already said, you have on the website a data button on the top banner, from where you can either go through the catalog and search through all of the data sets that are available, and select any area of interest, any particular data set that you're looking for, and have a look at which data are available to you. Or you can also use the viewer that's available, so you can immediately visualize the data that you would like to work with, which will give you some idea of, is this data usable or not for the application or the solution that I'm developing. But I will pass it on now to Mark to talk about the air quality data in the WEkEO DS, as that is of interest for the demonstration later on. Good morning, Mark. Yes, there you are. You're still on mute.
Okay.
Hi.
Is that better? Can you hear me now?
Yes.
Okay, great. Okay, thanks, Anne-Catherine. So, hello to everyone. Yeah, I work at UCMWF in the team led by Vincent Henry and delivering the Copernicus Atmosphere Monitoring Service. And I'm just going to give a sort of brief overview of the CAMS products that are available currently in WEkEO, and to fill in the gap, or well, to fill in one of the gaps that was left in Anne-Catherine's presentation. So the data that is currently available on WEkEO falls into these four broad categories. So regional products for Europe, global products, supplementary products, and emission products. I should point out that this is not currently an exhaustive list of all the CAMS products that are available, but where they're not available on WEkEO, they are available with a few exceptions on the ADS web interface and through the ADS API, which is the Atmosphere Data Store, which is part of CAMS. And I'll provide the link, and I'll provide some information on the data sets not currently available on WEkEO as we go through the presentation. So I'm just going to step through those four broad areas, and just to give a few comments on the data sets that are there. So we'll start with the regional products, and this is for the European domain. So what we have here is air quality analyses. That is the model combined with observations, and those are in situ observations from ground-based measurement networks that are assimilated into the model to initialize 4-day forecasts. This is providing data from a suite of 9 individual models, air quality models. But we also produce in near real time, along with those individual models, a multi-model ensemble which provides the median output from those individual air quality models. And often this is an enhanced product, and it is often performing better than the individual models in themselves. And these models all provide outputs that are based on inputs that are consistent. So the emissions inventories and the lateral boundary conditions are consistent between the models. Spatial resolution is about 10 kilometers, and the temporal output is only dividing air pollutants. So for example, ozone, NO2, SO2, various other things, particulate matter, including dust and pollen. The next product is the global products. Currently on the WEkEO, only the CAMS global reanalysis of atmospheric composition is available. So there's some information on there what a reanalysis is if you're not familiar. Essentially, this is a self-consistent data set with an approximately 80 kilometer spatial resolution that covers the period from 2003 to 2020. And every 6 months, updates are made to bring the information closer to real time. There's about a 6-month delay though. We of course have other global products which are currently only available through the ADS web interface and API. These are our sort of main workhorse products, which is the operational analysis and forecasts of 5 days for global atmospheric composition. They run at about 40 kilometers spatial resolution. And also to complement the reanalysis of global atmospheric composition, the data that's there currently is basically aerosols and reactive gases, but there is now also a full reanalysis of global greenhouse gases, which are available through ADS. The next topic is the supplementary products. So Vincent Henri already showed some examples of the solar radiation. So I maybe don't need to go into this in a lot of detail, but basically we're providing clear sky conditions at global scale, cloudy conditions just for the meteosat field of view, which is over geostationary over Europe and Africa, and provides data back to 2004. There are other supplementary products available, and these include the global radiative forcings, which are not currently on WEkEO, but are available through the ADS. The emissions products are basically currently emissions inventories. So the emissions inventories are based on national level reporting of emissions to provide at the global scale then emissions of all relevant atmospheric pollutants, plus also divided up into a number of sectors such as traffic, shipping, industry, and various other sectors. And so it's quite a comprehensive data set that covers the period from 2000 to 2020 and has a spatial resolution of about 10 kilometers. The other product is the greenhouse gas fluxes. So this is an inversion system which runs a model for a long period of time, but includes information from in situ observation networks. And this covers 3 different time periods depending on the greenhouse gas you're interested in. For CO2, it goes back to 1979, but for methane, just back to 1990, and for nitrous oxide, back to 1995. We also have a number of other emissions products which are not currently available on WEkEO, and also right now they are not currently available on the ADS either, but they are scheduled to be added and eventually to WEkEO. So these are global wildfire emissions from our global fire simulation system, plus also regional emissions inventories for Europe. And if you want more information on those, you can contact either the WEkEO support or the CAMS support. And just to finish off, so this is some useful links that you can look at in the presentation offline for access to direct help from CAMS on accessing data from the ADS, and also any issues arising from trying to access that data, and also our Twitter feed. But of course, the main port of call for any issues with data on the WEkEO portal is given here. And with that, thank you for your attention.
Thank you, Mark. We will be moving on now that you know which data are available. We will be moving on to the demonstration of air pollution monitoring using Copernicus data by Julia. Hello.
Thank you, Anne-Kathrin. One moment, I just make sure that you see my screen. Do you see the Jupyter Lab interface?
Yes.
Okay, I expect so. Okay, yes, so good morning from my side as well. My name is Julia Wagemann, and on behalf of EUMETSAT and together with the company WEkEO, which is in Italy based and delivering all sorts of services related to Earth observation products, I developed a Jupyter Notebook course on atmospheric composition training, and you already got a very nice introduction to the WEkEO platform from Amine, and also a nice introduction about the atmospheric composition products available from the atmosphere monitoring service from Copernicus. And I will now, the next 30 minutes, introduce you to some practical examples how you can make use of the data. And I focus specifically on two different data products, which specifically also Vincent pointed out that they show nitrogen dioxide, but in fact actually different types of or like they're like not comparable per se. And so I start with the CAMS European air quality data set, and then I will focus on the Sentinel 5P tropomi data. And just to let you know how you can also access the material we have prepared, is that if you already have an account on WEkEO, you can, as Amine showed you, you can log into the portal on wekeo.eu and you can go to the Jupyter Hub, and then the Jupyter Hub starts. So, and this is the interface, how it looks like. And you will have two folders, which are called public and work. And if you go to public, you have already a wide range of materials which have been prepared specifically for WEkEO training on different domains. So including atmosphere, but also climate, ocean, and also land. And so this is already made available for you on WEkEO. If you don't have an account and you would like to make this, or you would like to access this material anyway, you can also go to GitHub. And if you go to WEkEO/ and then the repository WEkEO-Jupyter-Lab, you can also clone the same content, which is already available here. You can also clone it from this GitHub account. And I will also paste the link to the GitHub account later on in the chat. So if you go to the public and then to the atmosphere folder, you see two folders. So one contains the material that has been developed for the WEkEO training event, which took place last October, and the folder 2021-05. So for May this year, WEkEO webinar. If you go there, then this is the content that has been developed for today's session, and you can have a look through it also even after the webinar. So you see already here a set of different notebooks, and as I said already, we focus on two different data types. So the CAMS European air quality forecast and the Sentinel 5P tropomi data. And for each of the two data sets, we have two notebooks. And the first notebook is I just open an example here, but we will not specifically cover it today. So this is basically an example how you can retrieve the data sets which we will make use in the training with the help of the Harmonized Data Access API. So Amine showed you already that there is an API which is called Harmonized Data Access, HDA API, in order to retrieve data that is available on WEkEO. And so for both data sets, the CAMS European Air Quality Forecasts and also the Sentinel-5 Tropomi data, you find a notebook which guides you through the steps in order to retrieve the specific data you need for the training. And for you, because the data is not available yet on the platform, so you would need to retrieve the data first in order to do the training on the two data sets. And the same, so this is an example how to retrieve the CAMS European Air Quality Forecasts, but the same is also available for the Sentinel-5P Tropomi data. And with this, I go back to my work folder, because there I already prepared the data for today's training. And I open the notebook 11, which is an example how to visualize the CAMS European Air Quality Forecast data, and specifically nitrogen dioxide for Europe for a specific for 3 days in advance at the beginning of February, where we saw elevated or increased levels of the surface concentration of nitrogen dioxide. And this is exactly what this notebook showcases. So we go through the different steps that are required in order to load the data, to understand how the data is structured, to load the specific variable, and then to visualize the nitrogen dioxide at the surface over Europe for 1 day. And then we can also animate it to animate the nitrogen dioxide forecasts over 3 days. And so the CAMS European Air Quality Forecast data are available either in GRIP or NetCDF, and you can retrieve the data either from the ADS, which is the abbreviation for the Atmosphere Data Store, or you can retrieve the data from the WEkEO directly with the help of the HDA API. And if you want to do so, then you can open the Notebook 10 CAMS European Air Quality Forecast, and which helps you to retrieve the data. And so if you're not very familiar with Jupyter Notebooks, so this is how a Jupyter Notebook looks like. It is a combination of different type cells or cell types. And so we have cells which contain markdown information, so which is a simple text where we can add some description. And we also have cells which are coding cells, and these ones we can also execute. And this means then we can execute the workflow, and we can go through our data analysis or data preparation and visualization. In order to execute a coding cell, you have two opportunities. So you initiate a cell just by clicking on it, and then you see the blue color, so you see it is activated. And if you want to execute it, you go to this arrow, and then you run the selected cell, and then it is executed. So in this cell, we just loaded some Python libraries that are required and which we need in order to visualize the data. Or you can also use your keyboard, and if you activate a cell and then you use Shift and Enter, then you also execute the cell, and you can go through a workflow as well with the help of your keyboard. We make with the training we also make use of a set of helper functions, which you can see in the notebook functions.ipython notebook. And so we with this cell here, we run the functions notebook and every content which is there. So if we open this functions notebook, you see that the notebook contains a set of functions which just help us to load or reshape specific data set and also to visualize functions. We don't make use of all the functions, but we run this notebook in order to have all the functions available. And so I execute this cell, and then just to check if the functions are available, you can, for example, enter a question mark and then the name of a function. So one function we will make use of is, for example, visualize underscore p color mesh. And if we enter the question mark and then the name of the function, visualize p color mesh, and we execute it, then the doc string, so the description of the function opens up. So this means, yes, this function is now available for us to use in this notebook. And we also see the keyword arguments that are needed for the function, and also a description what this function is doing. And this can be very helpful, especially for you if you're not very familiar with the functions yet. And with this we start. So the comes European air quality forecast data, as I said already, is available in GRIP or NetCDF. And the data, we retrieved it in NetCDF format. And with the Xarray Python library, we can open, so it's a very efficient library that is very efficient in handling NetCDF data. And for this, we use the Xarray function open underscore dataset, which helps us, or which allows us to open NetCDF files. And if we apply this function with the data for this training course, so I retrieve the data and it is NetCDF format, and I execute the cell, we see that a Xarray data set is loaded. And an Xarray data set is in principle a file which can contain more than one variables. It can, so one to multiple variables. And in this case, we see that this data set contains only one variable, which is the nitrogen dioxide surface concentration. And our data set, we see here that we have 4 different dimensions: latitude, level, longitude, and 13 different time steps. And so, so if we inspect the different coordinates of our file to understand the file and also the data structure better, we can start with the time information, for example. And if we execute this cell here, we see that we have 13 different time steps, but it is in nanoseconds format. So from 0 days to 3 days advance, but it is in a not very human readable format. And for this, we can use we can create our date time object, which helps us to create a more human readable list, which we can then make use of to visualize the data properly and also to understand the time information for which time and day the forecast is valid. And with this, we retrieve the information from our long name, from our data set, which we just loaded. And we use it from the time information. We see here it is the forecast with the run, which was initiated on the 4th of February 2021. And we retrieve this information, and based on this information, we create a timestamp, a date time object in Python. And with this, we have here now our datetime object, and based on this datetime object, we can build a datetime index, which is a list of different datetime information. And there we say that we start with our initial run, which was on the 4th of February at 0 UTC, and then in 6 hourly time step until 13 time steps, we create our datetime information. And then we see that for the next 3 days we have forecast information of the nitrogen dioxide surface concentration, and we can then, once we have our time information, we can assign this to our data set to have the human readable time information. And we do this with the function which from X array with the function assign underscore coords. And then we can say to the time dimension we want to assign this datetime index object. And then if we do this, we see that our time information is now more readable. And at the same time, we can inspect latitude and longitude information, for example. And if we do this, then we see that on latitude and on longitude, the information, the data is on a 0.1 times 0.1 degree resolution grid, around 10 kilometers. But the longitude, we see already here, the longitude information is on a 0 to 360 degree grid. And in order to have it in a visualization, we know often, or which is also often used, we bring the longitude coordinates. So we bring the longitude coordinates from a 0 to 360 grid to a minus 180 to 180 grid. And to do this, we can again use the function assign coords. And in this time, we want to reassign the longitude information. And with this cell in code, we can shift and reassign the coordinates and shift the longitude information from 0 to 360 degrees to minus 180 to 180. And if we do this, then we see already here the longitude information is now shifted to a minus 180 to 180 degrees grid. And we can also assure this again by loading the longitude information. And we see here now that it is covering Europe from 100 minus 180 to 180. And then, so now we are in a position where we understand better how the data is structured and also the data set itself. And now we want to actually load the data array in the variable, the nitrogen dioxide concentration on the surface, because this is the information we want to load. And then we basically can load it with just taking our file information or our data set, and we can say we want to load the name of the data variable, which is NO2 underscore concentration. And if we do this, then we load the data array, which also has 4 dimensions: time, level, latitude, and longitude. But additionally, we see here also additional attribute information, such as the species, units, or the standard name. And these attribute information are very helpful, which we also can use when we want to visualize the data. And so when we want to, and for later, for visualization, we want to store now the standard name, which is the mass concentration of nitrogen dioxide in the air, and also the unit information, which is micrograms per square meters, because this information we can then use for our plot and for our visualization. And this is what we do here. And the same we do just for convenience purposes. We store the latitude and longitude coordinate information of our data array as separate variables, and we call them latitude and longitude. And this is what we do here. And the next step is already that we can visualize our nitrogen dioxide information over Europe. And for this, we can make use of the function visualize underscore p color mesh, which I already showed you that is part of the functions notebook. And this function makes use of the matplotlib's function pcolormesh and also the CartoPy library, which is a very powerful library in order to nicely visualize data on different grid types and different projections. And so if you want to know more about the keyword arguments, I already showed you that a way how you can see the docstring information of a function. So you just enter the question mark and then the name of the function, for example, visualize _ pcolormesh, and then you see the keyword arguments a function requires. And this is, and here we apply this function with the required keyword arguments. And so we need the data array, so which is in our case, the nitrogen dioxide concentration. We need longitude and latitude information. We have to define a projection. And in our case, we make use of the plate Carré projection. We define a color scale which you can also easily change. So you can also try out different color scales. And here we make use of the variables we assigned before. So specifically units and also long name information, because this is directly the information which comes from the data set. We also specify the minimum and maximum bounds of our color range in order to tailor the visualization. And we can also make use of the longitude and latitude minimum and maximum bounds of the data directly, because as also Mark said, the regional products which are specifically for Europe, and the data set here we showcase is the European air quality forecast information. And then we have a set global keyword argument. So in case we want, and this is just identifies if we want to have a global map or just a map for a geographical subset. And in case we just want to have a map for Europe. And if we execute this the cell, then we see a visualization coming up for already one of the forecast steps. So for the 6th forecast step, which is the forecast for the 5th of February at 12 UTC. And we see here already quite elevated nitrogen dioxide information on the surface. We can also do here, for example, the initial run, which is the 4th of February at 0 UTC. And then we see here that the information also like here in Northern Italy is quite elevated. But in order to see how the nitrogen dioxide information also evolves over a period of 3 days, we can animate the information. And here is a code which allows you to animate the nitrogen dioxide information. So we apply again here the visualization function with our initial run. Then we say that we have 13 time steps over which we want to animate the information. And then we have a set of functions which helps us to animate. So we have a function that updates our visualization for each of the time steps, where we say, so for the animation, please update the visualization for our different time steps. And also update the title, because we want to see for which of the forecast or which day and time the forecast is shown. And we have a function which initializes the animation, and then we have a function which just calls the draw function to say, please animate it over our time steps. And if we do this, then and then we have a video which we can directly also showcase in a Jupyter notebook, and then we see here the evolution of the nitrogen dioxide on the surface from the 4th of February up to the 7th of February at 0 UTC. And you see that specifically on the 5th February at 6 p.m., we have quite high or increased nitrogen dioxide information, and as well at on 4th of February at 6 p.m. And with this, I just see that I would just go to the Sentinel 5P data, just to showcase you that how Sentinel 5P data can be prepared and also visualized, but at the same time, just to point out that the Sentinel 5P data, they show the tropospheric column of nitrogen dioxide. So the nitrogen dioxide information between the surface and 10 kilometer up to 10 kilometers in atmosphere. And so you can open the notebook 21, which showcases you the visualization of Sentinel 5P data. And the structure is the same. We just so we make again use of the functions notebook, and we also load some functions, some Python libraries we need for the workflow. And again, we load the functions that these functions are also available for this specific workflow. And then again, we start with the X-array function open _ dataset, and because the Sentinel 5P data is also available in netcdf, but how the data is structured, they are structured in different groups. And in order to get the information, so the data itself, they are stored under the group which is called product. And we can specify also a group keyword argument in the open dataset function. And for Sentinel 5P, we have to do this. So we say here, please open this Sentinel 5P data file, but also at the same time, we want to open the information which are stored under the product group. And if we do this and we execute the cell, then we see a data set again, but with a range of different coordinates and also many more data variables compared to CAM's data set. And so we see here that we have data variables related to delta time, the quality assurance value, but also nitrogen dioxide tropospheric column, and averaging kernel information, etc. And also the dimensions, they consist of 8 dimensions. So we see dimensions are scanline, ground pixel, time, corner, layer, vertices, polynomial exponents. And so there's many information, but important information we need in order to visualize Sentinel 5P data is time, scanline, and also ground pixel. And so the next step is to, out of the rich set of 12 data variables, we would like to load the one variable of interest for us, which is nitrogen dioxide total column. And if we can do this, we can do this, for example, by specifying the name of the variable in squared brackets. This is just a different way, but you can also use the data set and then dot and then the name of the variable. And if we do this, then we see that we have now loaded our data array, which is the nitrogen dioxide tropospheric column in the unit mole per square meters. And we also have a set of attributes, so the standard name, the long name, and also a multiplication factor. And we will just come to this in a short while. And at the same time, we can, and here we also see that additionally to our scan line and ground pixel information, we also have here latitude and longitude information. And if we retrieve this information, we can see that we have latitude and longitude information at the same time as well, that these latitude and longitude, they also consist of scan line and ground pixel information. So this is what I said is the important information. And if we then go to the next step, we can also retrieve our array values of the variable with square brackets. And so one single time step can be selected by indicating the dimension position, which is on the first position. And then we can say we want to have the first index of the time dimension. And if we do this, then we end up with a two-dimensional data array, which consists of the scan line and ground pixel information or dimensions. As said already, so the data comes with a multiplication factor, and this factor is used to convert the data, which is given in mole per square meters, to molecules per square centimeters, because this is a common way to visualize nitrogen dioxide information in molecules per square meters. And so for this reason, we store the multiplication factor as conversion factor. And then at a later state, we can also apply this conversion factor in order to convert the data to molecules per square centimeters. And at the same, we also store the long name information, which we can then make use of also when we visualize the data. And the next step is to create a geographical subset of our Sentinel-5P data, because we want to have just a European focus. We specify latitude and longitude minimum and maximum information, and then we can apply the function generate geographical subset, which applies the latitude and longitude bounding box information to our data array, which showcases the nitrogen dioxide information. And if we do this, then we see that our scan line and ground pixel information have decreased. So from formerly scan line information over 4,000 pixel information, we have now just less than 1,000. And in the next step, we actually can already visualize the data. And before we visualize the data, we want to apply the conversion factor, which allows us to convert the data from mole per square meters to molecules per square centimeters. And we can just use this by multiplying the conversion factor. And we execute this, and then the information is converted to molecules per square centimeters. And the final step is then again to apply the visualize p color mesh function to our subsetted and converted Sentinel-5P nitrogen dioxide data array. And for convenience purposes, we multiply the nitrogen dioxide information with the factor 1 to the power of -15, just to make the visualization easier. And then we can execute the visualization, and then we see the nitrogen dioxide tropospheric column information for 5th of February 2021. And we also see that the Sentinel-5P tropomi sensor indicated elevated nitrogen dioxide information. And with this, I would just invite you to have a look to the training material even after this webinar. And I thank you for your attention. And I will give back to Anne-Kathrin. Thank you.
Thank you very much, Julia, for the demonstration. This was very useful to see how to work with both CAMS and Sentinel-5P in a Jupyter notebook. In the meanwhile, we've been getting quite a few questions. Very briefly, before we go to the questions, I will let you know that this is a part of a series of webinars, and if you are interested in learning more either about the WEkEO DS or any of the applications from Copernicus related to air pollution, marine, land, there will be several more webinars now in May and in June. We will start thematic webinars for experts very soon, but I'm sure that with the training from today, and if you have a little look yourself, this could also be very useful for you if you want to have a refresher or some more information about specific applications. And you will receive automatically, as you're registered to this webinar, an invitation right after this, the end of this webinar. So let's move on to the questions and answers. Perhaps the first one that I saw coming up quite often is, will the slides be available? So this webinar is being recorded, and you will be able to get see the recording through YouTube after the end of this session. Then the next question would be about what's the difference in using WEkEO Cloud and your own cloud cluster if the data has to be downloaded using the CSD API in both? Vincent-Henri?
Yes, thanks, Abnil. That's a good question. In fact, yes, you could invoke the API from the CDS or ADS directly. Where the value of WEkEO comes is if you want to combine data that is in the CDS or ADS and data that is elsewhere, and also the other added value of WEkEO are the possibility to have virtual machines, as was explained by Amin. So if you want, WEkEO offers an extra layer or the layer of cloud computing infrastructure as a service to users who not only want to download data or to do very simple processing of the data, but also want to do more advanced methodologies. But yes, you're right. You can invoke directly the API.
Thank you. I hope this answers the question, Abnil. Next question. Is there a table of the datasets by spatial resolution? So what you can do is for the datasets you're interested in. So for example, for atmosphere monitoring, you can always go to the specific website of the service and have a look at which datasets are available on which level and get more information about the spatial resolution. There is a question about smog as a problem in our country due to stubble farming. Does the WEkEO platform give information with regards to smog or locust distribution? Mark?
Yeah, hi, Pavan. So I tried to answer it in the chat, but I'm not sure if it came through. So locust distribution we don't currently have, but I know there are other people who have looked at applications of using say weather forecasting data to then look at these kind of, sort of vector approaches to looking at locusts and things, but it's not something that comes under CAMS. In regards to smog, so we have estimates or near real-time estimates of fire. So this could be a forest fire or open burning, such as crop stubble, residue burning, based on satellite observations that we update on an hourly basis. So we have the estimated emissions for when these fires occur, and then we have the air pollutants that constitute photochemical smog, so ozone, nitrogen dioxide, PM 2.5, and so rather than actually have a smog trace, if you like, then we actually have the constituent pollutants that can impact on air quality in general. So it depends on the environment as to exactly what that smog is made up of. So in principle, you can estimate it for yourself, or you can use those pollutants as a proxy for estimating smog, but in itself, we don't have an individual product.
Okay, thank you. Does COMS data calculate heat budget?
For me again. So again, I don't think we have a product that's specifically heat budget, but one thing that I didn't have time to make clear is that all our forecasts also include output from the numerical weather prediction side of the model. So our model is a numerical weather prediction model, which includes all the chemical tendencies and sources and sinks. And we do archive and save the meteorological data. So in principle, you can calculate the heat budget from the data. But what I would say is that it's quite coarse spatial resolution, and there are heat budget products available from the Climate Change Service, which are at higher resolution, both temporally, spatially, and cover a longer period of time.
Great. Does the Sentinel 5P satellite provide better spatial resolution than COMS?
I'll answer this one as well. So Henri already gave an answer in the chat, I see. So I would just echo what he said. That yes, in principle, the field of view of Sentinel 5P is 7 or so kilometers, and the output of the CAMS global system is about 40 kilometers. However, Sentinel 5P is only observing at one part of the day, and only in daylight hours, and only when there's no cloud present, whereas CAMS is sort of filling in all the gaps of these, not just Sentinel 5P, but all the satellite products, to then provide a more consistent picture, including the 3D structure of atmospheric composition, so not just the total column that's observed by the satellites.
Yeah, so it's a trade-off and depends on the application that you are developing, which data would be more relevant. How do you get access to the code created for today's webinar training? Julia, I think you've also been answering a little bit in the chat on the Jupyter notebook that you've created.
Yes, it was Sabrina, so we created it together. Yes, what I said basically, I will I will share the link to the GitHub repository where you can get in the training for any WEkEO related event, and then you can clone it to your local machine, or if you have a WEkEO account, you can log in and go to the Jupyter Hub dashboard, and then you will be basically in the same system as I was when I presented it, and then you go to the public folder. And this is basically a clone of the GitHub repository of the content there. So, and then on the GitHub repository, you can go to the atmosphere folder, and you see the training prepared for today's webinar, and also last year for the training on atmospheric composition on WEkEO. But I just post the repository link there, and then you can get it. Okay, already someone, yeah, okay, yeah. Perfect.
So it's already in the chat for those that are interested in the direct link. How do you debug or check intermediate values in the Jupyter notebook?
Well, yeah. So there is so Jupyter Notebooks is an entire ecosystem, and there is a lot of development which is going towards a proper software developed environment. However, I would say that like Jupyter Notebooks is probably not the best choice if you also really want to debug any code. If you want to check intermediate values, you can just simply do by what we also showed there, that you can just print the information. So you don't even have to use the print statement. You can just add the variable name into a cell, and then you can execute a cell, and then you see the printout. And so this is basically how many people with Jupyter Notebooks also work, and also to check intermediate values in Jupyter Notebook. I think this is helpful. Oh, I hope this is helpful.
Thank you. Indeed, so as was mentioned already before, the recording of today's webinar will be available on YouTube, and you will get a link to it. The audio said we had to download the data before the training. So which training notebook tells us the code to download the data for the training? As just mentioned, so there's a direct link to the notebook, I believe.
Yeah, so basically the training content on the repository contains two notebooks, so the notebook number 10 and the notebook number 20, and they have the retrieve example or retrieve workflow, how you can access the data with the help of the HDA API directly on WEkEO. And so basically you don't have the data yet available, but you have the notebooks which you can go through in a step-by-step manner in order to retrieve the data. And this is just a matter of some minutes, and then you have the data for the specific training.
Great, thank you. I believe we're at the last question. Is data available using OpenDAP, DAP, so that no downloading is required? Perhaps Amin can also support on this.
I never heard of OpenDAP, but I can make a little research about it. So do not hesitate to send us a message to the support, and we will most certainly answer your question.
Okay, thank you very much. Thank you all for attending today's webinar and for the interaction in the chat and all of the questions. We hope you found it useful and that you revisit the recording on YouTube to learn more and to try it out yourself. Make sure to also have a look for the next webinars also on atmospheric data if you want to get more into the topic. And I wish you a pleasant day.